Hello and welcome to another Developer Essentials. So this time we're going to be taking a look at something called loops and iteration. So this is something where if you haven't already had a look at the video on containers, so looking at stuff called lists and arrays and dictionaries, that's something I'd really recommend actually checking that out first. Because the stuff we're going to be looking at with the loops and everything today, we're going to actually be making a lot of use of those lists and arrays there. So it'd be really helpful if you've already seen that beforehand. So let's just dive straight on in. We're going to set up our scripts folder again. Again, I'm going to go for creating a cube. And this, I'm just going to set up a script that is going to be called loops demo. And this is going to be loops demo 1. So we'll likely have a few different demo scripts with this. There's not actually going to be too much that we're doing in the particular scene. It's mostly going to be stuff that we're focusing on in the code itself. All right, so we've got a lot of different types of loops. That's a really key thing with this. There's actually many different types of loops, and which one we want to use depends upon what we're actually doing with it. Different loops have different situations that they are better suited for. So we're going to take a look at a couple of different ones. So firstly, I'm going to get this up so we've got some data. So I'm going to set up list of strings, and this is going to be first names. So similar to in the lists and arrays, the containers video there, where I was looking at that. Just getting some data set up here, and let's set up 5 different ones. I'm going to keep the names simple, and also then just avoids me needing to try and make sure that I can actually reliably remember 5 unique names, because it's one of those things where I feel like if I then had to, I would probably struggle and probably even forget my own name. So in the interest of not doing that, let's have a preset set of ones there. So we've seen before where with something like of this, if I wanted to display each element, I could, debug log first names 0, and I could repeat that for each entry. Starts to get messy once I've got lots of entries in there, because I would need to then start to do things like, okay, well, f first names count is greater than or equal to 4, then I can display number 3. Maybe make that a little bit neater and have it like that. But I need to actually do a check before each one. And anytime I change the size of that list, it potentially gets really messy. That's not nice code. That's not the way we want to be going and working with displaying everything in the list. And that's where iteration or loops come into hand. So loops are a way of allowing us to do a particular task multiple times. And that's the key thing. They allow us to take a block of code and we run it multiple times. So one of the really common things is, so like this first names, if I'm wanting to display all of those, so I'm wanting to do an action with everything in that list. And the reason I'm sort of, explaining it in that way is this is part of how we decide what loops we want to use. So that case where I'm wanting to perform the same action with everything in that list, that is a great example of where I could use something like a for each loop. So what that's meaning is for each thing that is in this list, perform a particular action. So I'm going to do something that we haven't seen before, and I'm going to write var name, first name, in first names. So var is kind of a magical type. but very specifically good magic. So it's magical in the sense that I could actually explicitly put string here, but then if I changed string, I would need to make sure I update that, or otherwise I'll get errors. It's also longer to type. Var is much shorter. Var is able to become any type. Now, it's not a case where, okay, mid this loop running, var could switch from being a string to being a float or a 3D position. It can't do that. What it does is the code looks at the context that I'm using it in. So I'm saying, okay, we've got a variable called first name, and it's coming from this first names list. So it can see list is a set of strings, which means this has to be a string. So var becomes string. So it looks at the code in context and it analyzes it and it works out what that variable type must be. So it's a reliable and safe thing to use there. I am a big fan of using it in particular for things like our for each loops. It's a really, really nice little time saver there, especially if you've got really complex verbose types, which sometimes does happen. If you've got ones where, the name of that type goes all the way along, it's just quicker and easier to use var. So I'm a big fan of it. So this, perform an action, in this case, debug log, with all names in first names. So what I can do is debug log name, and that'll just display out every single entry there. So what happens is it will grab the very first name, it puts it into this variable, it transfers it into it, then this logic runs. When it gets to the closing brace here, it actually jumps back up to the top here and it checks and says, okay, do I have more data? If I've got more data, grab that next bit, put it into first name, run the code, come back up to the for each again. And it keeps going until it hits the point where the for each says, nope, no more data. And then it will just continue in running the code after that closing brace. So let's run this and see how this actually behaves. So we'll need our console up, obviously, and we can run this. And what we will see is we will get all of our names appear. And if we change this, if we add in another one, then it just works. So again, this idea of writing code that we don't need to modify the code when we change the data. Always handy, always saves a lot of time. So that's a for each one. That's super handy. What if I wanted to do something with every second one of these, for example, though? Well, I don't have that position information with a for each. So for each is great if you just want to do something with the actual data, the actual value in every particular one. But if I wanted to do something based upon not just the value, but where something is positioned, then that's something where I need a different type of loop. It looks similar, but it gives us that position information. So forming an action, I need to make sure I put my parentheses there. Action with both the value and position of that value in first names. So what I could do is we have this other thing called a for loop. So for each goes through everything in a list or an array. It's designed for iterating over containers of things. It's specifically set up for that. For loop can kind of use it with anything. So for loop, we often have a loop variable, and majority of the time, these loop variables are integers. They don't have to be, though. Your loop variable could be a float, could be something like a string. It doesn't have to be like a number, and in particular, it doesn't have to be an integer number. So I'm going to call this index. I'm going to have it loop while index is less than first name's count, and then plus plus, which we haven't seen before. Plus plus, so we can put that comment in here. Index plus plus index is the same as index equals index plus 1. Now you might also see cases where people write index plus plus, so the plus plus goes after. Now, in a for loop where it's used in this context, it doesn't actually make a difference. So plus plus index is also the same as index plus plus when it is used within the parentheses, when it is used within the for block. I'm going to put at the end. So here I could have put plus plus index and that would have been fine. Sorry, index plus plus. Now outside of that, it does have a different meaning, but in this context, it's fine. Now it's grumpy at me because I missed a thing. I am supposed to put 0. So this is the structure for a for loop. We create a variable and we give it an initial value. We then, our second entry here is the condition for that loop to run. And then we have our update condition. So I'm going to detail those out. So this runs once to set up the loop. This runs every time to check if the loop block can run. And then this runs at the end of every loop block. So the sequence is it will come in, it'll run this, it will check that we're valid to actually run, then it will run the block here. Then it will update the index. Check this, and then run the block. So the core parts that are looping are this, then this, then this. So if we were actually sort of indicating the order, this runs before the actual loop, then we check this, then we run the code, and then we update the index. Now you'll notice I'm using a more lengthy name here. I'm using a full word. And something you might have seen if you look up for loops online is you'll likely see cases where people are using things like I or J. I am actually very, 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 very strongly against that. There are not a huge number of programming hills that I will die on because I think a lot of them are silly. This is one that I will die on this hill 1,000 deaths over if I need to, in terms of advocating against using single character variable names for stuff like that, or at least in particular single characters where they don't necessarily have a strong meaning towards the value that you're using. And there are very specific reasons for this. At the moment, we're doing a really simple loop. And we're doing a very simple loop. It's just one set of code that will be inside there. But say I set up one, like this, I is less than 10, plus plus I, and then in this one here, and J is equal to 0. So I've introduced typos. And they're really easy to introduce because I and J look really similar. So this one here, J is getting set to 0. J has to be less than 10, but I'm never updating J, which means this loop would continually run. It would never actually stop, and we would have to terminate Unity and restart it. This is why I am very strongly against single character variable names, or at least single character ones where we're using things like I and J. The exception there is if I'm looping through a grid of data, I will use things like X, Y, and Z. But X, Y, and Z look visibly very different. They're easier to spot that they are actually different letters. I and J look very similar. L has the same problem, looks very similar to I as well. So I avoid using those ones because it's far easier to introduce problems. It is also far harder to spot those problems. One of the biggest problems we have when we are actually trying to track down errors in code is our brains, to an extent, work against us. So when we're looking at stuff that's written, we aren't exactly seeing what is there. We are seeing our impression of what is there. And the thing of, well, we see what we want to see. It's kind of true. It is an aspect of how our brains work. We autocorrect the text that we are looking at, which means we can be looking at text and we don't actually see the problem. I could look through this code dozens of times and be like, yep, no, it's got I, I've got J, yep, that's fine. It's really hard to spot those problems. And in particular, if you're trying to debug that when you're tired, if it's amongst a sea of lots of code, it's really hard to track down. These are problems that are very, very difficult to spot. So I use more verbose names, or at least characters that are very distinct, to lessen the possibility of errors caused by simple typos. That's the goal there, is to make it that, oh no, okay, index, I'm not going to accidentally sort of type that wrong. If I had a nested one in here and it was, so say I was looping through first and last names, I would end up doing something like first name index, last name index. It's much harder to then accidentally get typos with that because the words are much more different and they will also stand out as being more different. So that's why I will die on that hill of please don't use I and J and L as variable names and go for more verbose variable names, in particular in loops. And I'm very happy to die on that hill. But I digress. This, I've got my index, and I have, my array of things. So what I could be doing then is I could be saying name, and then I want to display the number, and I don't want it to start at 0, so I'm going to add 1 to it, is first names index. So we can still access the actual value, but now we have the index. It can be really handy. It would allow us to do different things with the first and last element or every second element. Just makes it a bit easier for working with. And if I run it, then we'll be able to see name 1, 2, 3, 4, 5, 6. So that's working. And that's what we want to see. So, okay, cool. Well, we've got for loop, we've got our for each loop. So these two are kind of interchangeable. They're probably the bread and butter loops. The majority of loops that you will be writing in Unity are going to be for each loops. Now, there is a performance difference, but that performance difference is not going to show up until you are working with very large amounts of data typically. So a for each is slower than a for loop. But unless you are iterating through thousands of things, you are not going to notice the difference. It's also important not to go too early in on trying to optimize the performance of your code, because more performant code is not always as readable. Quite often the opposite. It's quite often the case that really high-performing code is really hard to read. And in some cases, it can then mean that that code can only be maintained by experts in a particular area. I've had projects where that's happened, where we've had really complicated systems and someone has gone in and optimized it using genuinely impressive stuff and things that look at it and like, that is, yep, okay, that is bonkers, but kudos. And the downside there was they then were the only person in the studio who could maintain that logic because no one else had even the remotest chance of being able to maintain it, which was frustrating for them. And an example of you don't want to optimize some things too early. So for each or for, at this stage, with the general things you're going to be working with, I wouldn't worry about it. Use whichever one you feel most comfortable with, but I would try and alternate between them. Use a mix of both ones because it's really handy to remain familiar with them. Because there might be, there are cases where a for loop can be handier if you're needing that position information. There are sometimes cases where we do specifically need position info, so it's good to have that there. So, okay, for and for each, that's kind of cool. We can do more stuff than this. So I'm going to duplicate this. And what I'm going to do is a couple of things. So this is going to loop through all the first names. First names. If the name is Skip, then display nothing. If the name is exit, then stop displaying names. So, okay. So if the name is Skip, then I want to do nothing with it. If the name is exit, then I want to actually not display any names after it. So let's have a look at how I could do that. Because this thing, we can start to get a little bit more complex with our loops. And sometimes we might have a case where we don't want to process some information. We might be saying, okay, I want to process all of these. Nope, this one might be the thing I've already selected. I've already used it. So it's a case like, nope, I'm going to not use that one. I'm going to skip over that one. So what I could do is F first names and index is equal to skip. So this is an important thing. The way I check if something is equal to something else is I use a double equals. Single equals will set, double equals will check. So if it was skip, then, and this would be one way of writing this, is I could say, well, if it's skip, then do something, otherwise this, and that gets messy. Got a lot more indenting, things like that. It's a lot more lines of code, and I'm not a fan of that. Yeah, we could change this to, well, if the first name is not equal to skip, then we display it. And yeah, that works. Still, not always the neatest. I like to try and any sort of flow control stuff, any stuff where I'm changing that order, that sequencing of what's happening, I really like to do that early on and just have that almost kind of separate from the rest of the code. So how I would normally structure this is, okay, well, if first name's index is equal to skip, then I can do this thing called continue. So continue jumps right back up to, effectively actually it jumps to the end of the loop. So continue jumps to the end of the loop, skipping, and actually the end of the loop block, skipping over any code in between. So continue immediately jumps down to here, where it will update index and then run the check again. So continue is a way of basically saying, yep, no, don't run the rest of this loop, just come back around to the next value. So skipping, jumping ahead to the next value. So continue is great for that. And then first names index, if that is equal to exit, so related to continue, we have this one called break. Immediately exits the loop. So it won't run any of the remaining code here, just immediately exits it. So continue and break, you can use those in for each loops as well. So all of the loops we'll be looking at today, continue and break is supported in them. They only work within a loop, so you can't use them just anywhere in a function. They don't support that, but continue and break can be used in any of our loops. So for each, a couple of the other ones we'll be taking a look at. So let's see what that does. So we want to change this one to skip and this one to exit, and I am going to turn off collapse just so we can see it all up here. So we should, as the final set of things, see A, B, D, and then nothing. So we should see, that's all we should see happen. So it runs, we get A, we get B, and we get D, because we skipped that one, and we exited at that one. So continue and break are really handy as ways for being able to manage that flow of what's happening there. So this is something where, experiment with these for and for each loops. Now we're going to look at a type of loop that is more dangerous. It's a type of loop where, inevitably you are going to need to end task unity when you're using this loop. And, I've said before that there are a bunch of things where, yep, this type of error, just accept that it is now part of your life and you are going to run into it forevermore. This is one of those scenarios. So what I want to do is I'm going to have a public list, random health values. I'm also going to have a public int num health values needed. I'm going to say is 10. So I want random values here, and I want to keep going with and filling up that list until I have 10 of them. Now I could absolutely use a for loop for this. I could do something like this, where I have a for loop, and I can leave that first condition empty. I can say for random health values count is less than the number of health values needed. And again, I'm leaving the update condition empty. And I could say random health values add and pick a random number let's say between 80 and 120. So in this case, use a for loop to generate random values until we have enough stored. So a for loop could absolutely be used for doing that. It's not the neatest at all. Like I could use an index to count up as well, but I want to be a bit safer and ensure that there's definitely those values there. So a for loop would absolutely do this approach. There is a better setup for it that's a little bit neater. What that is something called a while loop. So in this case, we would say while random health values count less than number of health values needed, and then we run the same code. This is version 2. Using a while loop, we fill the list. So this is version 1. And we're going to comment out version 1. So a while loop doesn't have a initialization or an update thing like a for loop does. All it has is the condition. So as long as this condition is met, this block of code will run. And this is where the danger comes with a while loop and why we need to be careful with it. Because if I had something in here that meant we weren't adding those values in, if I commented that out, for example, that while loop will never end. It will continue running forever until we forcibly terminate the program. So it's very easy to have that happen, especially if you're in the habit, which is a good habit, of as you're updating code, save, go back and test, and like, cool, oh, I didn't add in the rest of the code to update this. So you could just have had that, this initial part, and I don't have the inner body. And it gets worse because Unity itself doesn't autosave typically. So that could mean I've done a whole bunch of code editing. I've done all this code editing, which is fine because the code editing's in a separate program. But maybe I've done a whole bunch of level building. I've been placing things all in the scene. I've spent an hour building everything. I've also been tweaking a lot of values. I've been adjusting and balancing things, and I haven't saved. And then I go and run code that has an infinite loop, and I have to end task Unity. And I lose all that work. And if this sounds like, a thing of, hey, that sounds like this is a deep and personal thing to you, that's because I've done it many times. And there are ways that you can break it out of a while loop sometimes, but not always. And we will have a look at those when we look at some more advanced debugging techniques. The key thing is to initially be cautious. In particular, you can get infinite loops with for loops as well. While loops, it's a little bit easier to have it happen with, just because we're not explicitly inside the loop. It's not one of the first things we're doing is writing the update criteria. So a while loop, this is a fairly standard usage of it. While we don't have enough of these values, add them into the entries. And we'll be able to see those will populate in here. So it'll run. We now have 10 random health values, which is cool. And of course, those disappear when we finish. So while loops, you're going to not use them very often. They are pretty infrequently used. I find that the main cases where I use them will be things like of this, where I am trying to fill something up, so fill up a container with data, or conversely trying to empty a container where I'm doing something while there are values there. So that's the main scenarios where I use a while loop, where I'm trying to fill up a container or empty a container. They're two really common usages for it. Outside of that, I generally would not use them. In particular, in update, and an easy thing that people can think of, oh, okay, no, I know what I can do. I want this thing to move. So what I'm going to do is, and it might be, let's say I want this to move over a period. I don't want it to take 1 second to move. So I might have a timer, and this will be my float current time. So what I could easily end up writing here is, okay, well, the current time is less than, say, 5 seconds. So I want this to move up for 5 seconds. And then what I could say is, okay, well, my current time plus equals time to delta time. And my transform position, lowercase t. I want to add into that, I want to add a new vector 3, and I just want it to move a really, really small amount. So, cool. So over 5 seconds, I want this to move up. And this is a block of code that's really common to see folks write. But what I am wanting is just it to steadily move for 5 seconds. But let's see what does happen. And it just shot way up in the air, and I'm going to move my game view here so we can kind of watch it happen. And we can turn off statistics because I don't think we're too worried about frame rate. But it just goes from being there to immediately there. It's not moving over 5 seconds. And that's because I put this in a while loop, because update runs every frame. So the very first frame update runs, it comes in and it says, cool, I'm going to keep doing this until current time is greater than or equal to 5. So I'm going to make it actually happen over that 5 second period. So a lot of times with folks, your instinct might be to set up a loop for doing things like movement. We don't need to. Because we kind of implicitly already have a loop there, and the update is getting run every frame. It's getting run every time. It's that loop block that we could do logic in. So we don't need to do stuff like of this in update, and we often don't want to do this. So I'm going to comment this out. Below is easy to write. Because what happens in that one frame, it actually 5 seconds passes effectively. This value increases up to be 5, but it's not really 5 seconds. So we're not getting the behavior we want. So while loops in update, in particular, if you're doing that because it's a case of, I want this to do this over a period of time, that's not the effect you'll get from a while loop in update. So be really cautious with where you're using while loops, especially early on. You're going to find that there's likely not a case where you need a while loop. Early on, what you want to be thinking with the containers is if you're doing something with every value in a list or an array, or most values, then think 4 or 4 each. With a 4 where you would need position and a 4 each where you just need the value. While loops, you should be looking at those for if you are filling up a container or emptying a container. That's the two times where you'll generally be using a while loop early on. Outside of that, I recommend not using them unless you're really confident that that's exactly what you're needing at that particular point. So that's pretty cool. Let's put this all together. And let's do something where we have a list of first names and last names, and we want to then construct a bunch of names. So we want to be able to put together a list of names and avoid duplicates. So this is something where it's combining a few different bits and pieces of things that we have looked at. So I'm going to come in here, and first thing I'm going to do is set up first names, my last names, and I'll set those up in the inspector. So what I want to do is I want to set up a list of strings, and this is going to be my chosen names. Remembering that because I haven't made this public, I need to new it. So what I want to do is I want to pick a first name, then pick a last name, put that into the chosen names list, and I want to make sure that I can't pick that combination of names again. So when I pick a first name and last name and store in chosen names, do not pick the same first or last name multiple times. So I'm just writing out comments of what I'm trying to achieve with this, which that's something where if that's a helpful thing for you, then absolutely be doing that, because this helps me work out what I want to actually be doing. So, okay, I need to work out how many I'm going to be picking as well. So, okay, my number to pick. Now, because I could have a different number of first names or last names. So I want to make it that, because they have to be, each one I can only use once. So whichever list is smaller, that's the number of unique names I can pick. So this is where I can use mathf min, first names count, last names dot count. So this week we're working out smallest number of names to pick with being unique. Now let's chuck in again, validity check the list of names. So in this case, if the number to pick is equal to 0, then we've got a problem. Because the only way that could happen is if both, actually if either one of them has no entries. So we make sure we provide a helpful error message, we indicate the problem, we indicate potential solution there for it. So that works. So we're validity checking. So we've worked out the smallest number, because if we had 3 in one and 4 in another, we can only pick 3 unique names. So if we get 0, that means one of these is empty. So now we can start doing our picking. So pick the names. So while chosen names count is less than num to pick. Now the nice thing with this is if num to pick is 0, this loop, nothing in it will actually run. It'll just do absolutely nothing whatsoever, because num to pick is 0, count, so 0 is not less than 0, which means this will never run. So to pick the names, what I want to do is my first name, it's first names, random range 0 to first name dot count, first names dot count. Do the same with the last name, and yep, I am copying and pasting because it makes it a little bit easier. So we pick a random first and last name. We remove the names so they can't be picked again. First names, remove first name. And we do the same with the last names. We remove last name. And then store the new name in chosen names. Chosen names add first name and the last name. And then the final thing, display all the names. Again, this is where we can use a for each. Chosen name in chosen names. And we'll just display it. So this is a good example where we're starting to use a mix of different things. So we're making sure that we are trying to pick the correct number, because if we had 3 in one and 4 in the other, we can't generate more than 3 names. We can't generate, if we generate 4, we would be trying to pick something from a list that doesn't have anything in it. We're displaying an error message if we know that we don't have data. We're then, while we don't have enough in our list, we pick ones. We remove them from their source list, so we can't pick them again. And then we store that name. And then finally, we display all that data out. So this is a common usage of where we're working with multiple different types of loops. And let's get these values set up. So we'll have A, B, C, D, E, and F. Again, we're just keeping it really simple. But this will then give us, we have our set of names, so A6, E3, C4, D2, B5, F1, and that will change each time because it is random what ones it is picking from. So this time A was with 2. So it gives us an easy way of filling up a set of random data like that. It's a really common approach using things like if this. We could use this for, if we were spawning things in a world, we might want to be spawning things from a set of stuff. If we are picking random attributes for characters, then we could be using like if this. So it gives us a way of setting up that sort of process there for it. So the key things that we want to remember with loops, we have 3 main types that we are making use of. For each is perfect when we want to just loop over all the values in a list, in an array, and where we just want to do something with the values. We're not interested in the position in that list or array, we just want the value. For each is perfect for that. We use a for loop if we also need position, because with a for loop, we can still loop through lists and arrays, but we get the position back. And that allows us to still access the value, but it also means if we wanted to do something with every second element, we could easily do that. When we're working with our loops, the for each one, we often use var, because var can become any type, and the syntax is for each, and we give it, here's the place where you can temporarily store things from this set of data in our container. And it goes through one by one, takes out the first entry, stores it in that first name variable, takes out the next, and runs through that with each individual one. After each time it does that, it runs the block of code here until it hits the end. For loops, we have more control over that. So for loops, we typically are setting up a variable. Integers are the most common ones there, but it could be a float, it could be a string, could be any type really. But we have our initial setup, and that runs once before the for loop. We have our criteria, our condition for the loop block running. So the loop block being the attached set of code. So we have a condition there. Then we have the update block. So after it runs the loop block, it will run this update block and then run the condition again. Now the update block, in this case we are adding 1, but we could be adding 2 or 573 or any value we wanted. If we were working with floats, we could be adding 1.3. So we can be adding different amounts there. What matters is just that this is for updating the particular variable you're using to traverse the data, to loop through the data. With our loops, whether they're a for each or a for or a while loop, we can skip that particular run using continue. So continue will stop running the rest of the stuff in that loop block, and it'll just go direct to the update. We can also break if we want to exit the loop immediately. That's something that we can easily do there. Break will force an exit of the loop. We have our while loop, which are while loops. We generally want to be using those when we are trying to fill a container or empty a container. We want to in particular be careful of using them in update. This idea of using a while loop there in update for moving a character is typically not going to give the behavior that you're after. And then finally, we can piece a few of these together and start using it for randomly picking items. And that allows us to make sure we're picking unique items and then be working with that. So key things when we're working with loops, make sure you're always, if you're doing a lot of scene changes, so if I was doing a huge amount of level building in here, I want to make sure I'm regularly saving. Just in the case of if I do create an infinite loop, I would need to typically end task unity, which means if I haven't saved recently, then I could lose any changes to the scene there that I might have made. So make sure you experiment around with these. Try setting up different for loops and while loops. Intentionally set up ones that are going to make Unity crash, that are going to cause infinite loops. Because it's good to get experience with saying, well, how does that look? How can you identify, well, this is now in an infinite loop versus, yep, no, something else has happened. So create those problems, run into them intentionally. As I said, we don't want to be avoiding problems at this stage. We want to embrace running into problems. Problems are a chance to learn, and running into those problems is actually part of the learning. Making errors, finding ways to fix them, those are actually part of part of the things we need to learn. So it's part of the process. So if you are working with this code and you've grabbed a copy, you've modified it, and you're now running into hundreds of errors, you haven't messed up. It's part of the learning process. Grab the version of the code that you know works and look at them side by side. Start to try and work out, okay, well, what am I looking for? Because early on, we don't necessarily know what we're looking for. So we need to, that's part of the learning, is learning what we're looking for with it. So grab the code, experiment with it. It's going to be something that will come with time, but don't be afraid of running into errors. Errors and problems at this stage are a good thing. They're stuff that we want to be seeing them. And that's why I really encourage doing things that will specifically cause errors so that you get to see what they're like, so you get to fix them. So grab the code, have an experiment with it, and see what sort of bits you can do, see what kind of errors you can create. Go for creating the messiest, colossal mass of errors that you possibly can, and then try and fix them. That's the key there with that. Thanks, folks. That is all for this video. If you're looking for the project, you'll be able to find it up on GitHub, and I've put a link to that in the description below. If you've got any feedback, any questions, please chuck in a comment. And if you're looking to find ways to support the channel, chucking in a like or subscribing to the channel is always a big help. If you're looking to go further than that, then I do have a Patreon set up, and any support there is super appreciated. And there's a bunch of different things that you'll get as part of being a patron there. And the big thing is, it's going to help me make more cool things like this, which is going to help more people like yourself to be making more games, which is awesome. And that is all for now. Thank you.